In this video, we are going to talk about the isosceles base angle theorem and what it means in isosceles triangles and how we're going to solve problems with them. So I would pause your screen and get this written down, then come back and listen to me talk about it and add in a few more things that you find useful. So the first thing that we're going to do is define some vocabulary. So when we're talking about an isosceles triangle, remember an isosceles triangle has at least two sides that are congruent. So those sides are called legs. So the sides that are congruent are the legs. So these two right here would be the legs. Then that other side would be the base. So the non-congruent sides would be the base. And then we've got some different types of angles. So we've got the base angles and the vertex angles. So the base angles are the angles on either side of your base. So remember this bottom side AB was the base. So the base angles are the two on either side of the base. And then the vertex angle is the one between the two congruent legs, or the one that is not one of the base angles. One thing to note is that the base angles are also across from the congruent legs. So we've got this leg here, so this base angle is across from that side, and this base angle is across from that side. Let me put those in different colors so that you can see it a little bit easier. So across from this leg is a base angle, and across from this leg is a base angle. All right, then we'll get into the base angle theorem. So what the base angle theorem says is that if you have two sides of a triangle that are congruent, so AKA we have an isosceles triangle, then those two base angles, the ones across from those two sides, so in this case angle B and angle C, are congruent to each other. Okay, so those base angles there are congruent. This one is congruent to this one, which we have right here. So those two angles are equal in size. So on a picture, what you could do is just, put your arc mark in there. Then we have the converse. So converse means you flip around the statement. So we're going to take this part and put it first, and we're going to take this part and put it second. So it just swaps those. So in the converse, it says if you actually see that you have congruent angles, so we see these two base angles that are congruent, then the sides across from those angles are actually equal as well. So this side AB is congruent to side AC. So now we know that those are the same in measure. So if this one happened to be 10, then this one would be 10 as well. Okay, as long as those base angles are the same. So the ones across from it. Then what happens is if we actually have an equilateral triangle or an equiangular triangle, they force each other to happen. So if you see all congruent angles in a triangle, that means all the sides are congruent as well. Or if you see all of the sides are congruent, that forces the angles to be congruent as well. So if you happen to see a picture like this, you would know all the angles are congruent as well. Okay, that forces it. And if you saw a picture like this with all the angles congruent, you would automatically know all of the sides were congruent. And in fact, since we know that the sum of the angles of a triangle is 180, if we divide that by 3, then we know that equilateral, equiangular triangles have 60-degree angles. So let's take a look at a couple examples here. What in the following triangles, which angles are congruent? So what you need to do is look for the two sides that are congruent. Okay, so in this case, we see this 3 and the 3 match. So across from those sides would give us the angles. So across from this side would say that angle B is congruent to angle C. And in this one, okay, again, look for the congruent sides. So the 6 and the 6, so AB is congruent to BC. So across from those sides, the angles opposite them are equal. So C and A. Again, look for the sides that are the same. So this one and this one. So across from those would be B and A. And then in number 4, kind of a trick question because all 3 sides are the same. So in fact, all 3 angles are the same. forces it to be equiangular as well. Okay, then let's take a look if we see some angle measures here. So angle measures, again, if you see two congruent angles, then the sides across from them are equal. So we see both of these are 50. So across from the 50 is side A. And across from this 50 is side B. Sometimes these will be labeled with, capital letters. So if we had done something like this instead, then you would have across from angle C would be side AB. And then across from this one would be side AC if they had capital letters on there at the vertex. These ones are just labeling the sides with a lowercase letter. So in number 6 here, we have a missing angle, okay? So you'd need to do 180 minus 110 minus 35, okay? Figure out what that is, and you end up with 35. So you found out that that angle was 35. So then you see that this angle is congruent to this angle, so across from those would give you the equal sides. So across from this 35 is C, across from this 35 is side B. So again here, do 180 minus 62 minus 56, and you'd get 62. So then you'll see that this angle is congruent to this one. So across from those equal angles, okay, so draw across from those equal angles to figure out the two sides that are equal. Subtract 60 and 60 from 180, get 60 again. So you get equiangular, which means that all three sides are the same. Then let's take a look at some examples that are more written out here. So it says in triangle MNO, NO is congruent to MN. So first draw yourself a picture, and then label the sides. So we'll say M, N, O. So this one is saying that NO, side NO is congruent to side MN. So you'll put a tick mark there. And then it's saying that the measure of angle M is 42 degrees. Find the measure of angle O. So I'm going to put an X in here as what I need to find. So now we see that we've got two sides that are the same. So you'll see this side is congruent to this side. So if you go across from those sides, you'll get the angles that are congruent. So this angle is congruent to this angle, which says that X is equal to 42, which in this case, X is angle M. So we could also, angle O. So the measure of angle O is 42 degrees. So make sure you label the picture based on what it says here. So drawing the vertices on and then marking up what it tells you. So here's another one. So triangle OPQ this time. So OPQ, get those labeled on. This one says QO is congruent to PQ, so tick marks on those sides. And then it also tells us that angle Q is 50 degrees. And then it wants us to find angle P, so it wants us to find this one. So again, we've got the two sides that are congruent here, which will help us with what angles are congruent. So across from this side is this angle, O, and across from this side is this angle P, which we've labeled X. So those two are equal. So this one would be X as well. So now, instead of knowing what this one is and just setting them equal to each other, now you know all three angles, or you have an expression for all three angles, so you can use the Triangle Sum Theorem. So you can just add all three angles together to equal 180 degrees. That's one way to do it. Sometimes, since this one is just a number, people will do 180 minus 50 to get 130, and then these two angles need to be identical, so then just divide that by 2. to get 65 degrees, which is going to be the same thing here because you're going to do x plus x to get 2x. Then you're going to subtract 50 from both sides to get that 2x equals 130. Then you're going to divide both sides by 2, getting to 65 degrees as well. So the measure of angle P is 65 degrees. One more where we're going to draw out the triangle here. So draw your triangle again. Label the sides. So W, X, Y. Doesn't matter the order you write those in. Angle X is congruent to angle W. So X is congruent to W. YW, so from Y to W, so this segment right here is 19. And WX is 15. It wants to know the length of XY. So XY is this side. Okay, well, we see two congruent angles. So across from those congruent angles, so draw an arrow, those sides that are across from those angles would be equal. So side XY would be equal to WY. So on XY we have X, and on WY we have 19. So we found out that it was equal to 19. Two more examples. So solve for the missing variables in each of the following problems. So take a look here. Okay, so look for where your variable is. So your X is in an angle. Okay, so we need to decide what we know about the angles. Now the sides will help us because we see that we have two congruent sides. So we see that we have this side and this side are congruent, which will tell us that this angle is equal to this one, which is going to be helpful since we're looking into angles. So we know this angle is equal to this angle. So we don't actually care how big the sides are. They have nothing to do with the angles, just the fact that we've got congruent sides to tell us which angles are congruent. So now we've got 38 degrees up here, and then these two angles are equal. So we don't know how big these are, but we do know this one is the same as that other one, so we can put 10x plus 1 in there. So now we have an expression for each one, and we could do triangle sum theorem. So 10x plus 1 plus 10x plus 1 equals 38. Whoops, that is wrong. Plus 38 equals 180, sorry. Okay, so add all three to equal 180. So combine your like terms. You'll have 20x. 1 plus 1 is 2, plus 38 is 40. Subtract 40 from both sides. So you'll get 20x equals 140. Divide by 20. And you'll get x equals 7. Whoops, I guess that whole thing will move. Okay, so the other way that you could do this one is by that second method that I said on the other screen, where we could subtract 38 from both sides. Or sorry, we could subtract 38 from 180, okay, which will give us 142. Then you could divide this by 2 to get 71, which would be how big each of these angles are. So then you could set this equal to 71 and solve that way if you want. So you could do triangle sum theorem, or since you know this is 38 degrees, you could take it away from 180, divide by 2, and figure out how big each angle itself is. Then you would subtract 1 from both sides, divide by 10, and you'd still end up with 7. All right, then let's take a look at this last one. So in this last one, we want this to figure out x from this angle. So this one's kind of cool because you're not even given any numbers in here, but you're going to be able to figure this out because all three sides are the same. So if all three sides are the same, that means that all three angles are also the same, which 180 divided into 3 equal parts is 60. So we actually know that this angle right here is equal to 60 degrees. So 3x plus 15 is equal to 60. So then you just need to solve, subtract 15 from both sides. So you get 3x equals 45, divide by 3, and you get x equals 15.